This video is a continuation of topics from day 7. So today we're going to identify the side of a triangle given a reference angle and identify a reference angle given the sides of a triangle. So in number 1, we want to complete a chart about our ratios. In order to do that, though, we need to know all 3 sides of the triangle. Right now we are missing our third side. So to find the third side, we're going to do Pythagorean theorem. So 15 squared equals 9 squared plus x squared. 225 equals 81 plus x squared. 144 equals x squared. So x is 12. Now that we know x is 12, we can do our ratio. So first, we're going to look at using the reference angle of D. So if I use D as my reference angle, I can label my opposite, my hypotenuse, and my adjacent side. So your sine is opposite over hypotenuse. So the opposite side is 9, the hypotenuse is 15. Now, today we can also reduce those fractions. So we are going to reduce this to 3/5. Cosine is adjacent over hypotenuse. So we have 12 over 15, which reduces to 4/5. Tangent is opposite over adjacent. So we have 9 over 12, which reduces to 3/4. When we switch our reference angle, we're going to change the opposite and the adjacent side. So if our reference angle is now F, we have opposite, hypotenuse, adjacent. So our sine is still opposite over hypotenuse, but the opposite side is now 12 over 15, which reduces to 4/5. Our cosine is 9 over 15, which reduces to 3/5. And our tangent is opposite over adjacent, so 12 over 9, which reduces to 4/3. Now we're going to be given the ratio and an angle, and we have to figure out what trig function that represents. So in the first one, we have 20 over 29 and angle R. So if we use angle R as our reference angle, 20 is opposite, 29 is the hypotenuse, which means we are using sine. If we look at angle A, we have 21, which is the opposite side, and 20, which is the adjacent side. So if we have O and A, we are using tangent. And then using angle A, we know that 20 is the adjacent side, 29 is the hypotenuse, so we are using cosine. So let's try another problem similar to the one we just did. This time we have angle N. We have 24, which is the adjacent side because it's next to our angle, and 25, which is the hypotenuse, so this would be cosine. Using angle U, we have 24, which is the opposite side, and 25, which is the hypotenuse, so we use sine. And again, using angle O, we can leave those two that we already had, or using angle U, we know that 24 is the opposite side, so 7 is the adjacent side, so this would be tangent. Now we have the trig function and we have the numbers, so we need to figure out what angle is the reference angle. So if we are using sine, that means we have our opposite over our hypotenuse. So we got to figure out 12 is opposite of what angle? So 12 is opposite of angle B, so it would be the sine of B. Cosine 9 over 15, that's adjacent over hypotenuse. So 9 is adjacent to angle B, so we would have the cosine of B. Then we have tangent, which is opposite over adjacent. So if 9 is the opposite side and 12 is the adjacent side, we are taking the tangent of N. Number 5, given triangle PIG, if the cosine of P is 12 over 37, find the sine of P. So we're going to draw a triangle, and we have a right angle. The only angle that we need to label our triangle with is P. I always put P in the bottom corner so I know it's not the right angle. So if I have cosine, I have the adjacent and the hypotenuse. So based on angle P, we have opposite, hypotenuse, adjacent. We know the adjacent side is 12. We know the hypotenuse is 37. So in order to find the sine of P, we know that the sine of P is our opposite side over our hypotenuse. But we don't know the opposite side yet. So first we're going to do Pythagorean theorem. So 37 squared equals 12 squared plus x squared. So 37 squared is 1,369 equals 144 plus x squared. So you get 1,225 equals x squared. We take the square root, x is 35. So our opposite side is now 35. So the sine of p is equal to the opposite side 35 over the hypotenuse 37. Let's look at another example. Given triangle TUG, if the tan of G is 3 over 4, find the cosine of G. So I'm going to put G again in the corner, and I have my opposite, hypotenuse, and adjacent. Tangent is opposite over adjacent, so our opposite side is 3, our adjacent side is 4. In order to do cosine of G, we need the adjacent over the hypotenuse. So I need to do Pythagorean theorem first to find my hypotenuse. X squared equals 3 squared plus 4 squared. So x squared equals 25. So our hypotenuse is 5. So the adjacent side has a length of 4 over our hypotenuse, which is 5. Let's look at another example. Given triangle BIG, if the sine of B is 7 over 25, find the tan of B. So in our triangle, the only angle I care about is B. So based on B, we have opposite, hypotenuse, adjacent. If I'm given the sine, that's the opposite and the adjacent side. So we have 7 as the opposite and 25 as the hypotenuse. To find the tan of B, we need our opposite over our adjacent side. So we're going to do Pythagorean theorem to find that missing side. 25 squared equals 7 squared plus x squared. 625 equals 49 plus x squared. We can subtract 49 from both sides. 576 equals x squared. So x is 24 as our missing side. So our opposite side is 7 and our adjacent side is 24 to complete our ratio. So our last problem is an SAT problem. In a right triangle, an angle measures x degrees. Which sine of x is 4 over 5? What is the cosine of 90 minus x? So this goes back to what we were talking about yesterday. If I have two angles in a triangle, so let's say I have x here, which means the other angle is 90 minus x, sine is opposite over hypotenuse. So from x, the opposite side is 4, the hypotenuse is 5. But if we are looking from angle 90, and we're doing the cosine, that's our adjacent over hypotenuse, so it's going to have the same ratio as 4/5.